Hello, everybody. In this video, we're going to learn about scientific notation. Scientific notation is used to write really small and really large numbers really quickly. So what does scientific notation look like? Here's an example of scientific notation right there. What you can see is that you're first going to have a number, also known as a coefficient, and that number must be greater than or equal to 1 and less than 10. So this first number always has to be in between 1 and 10. We're always going to be multiplying it to a power of 10. And over here you can see a power of 10. A power of 10 is made up of two things. The base, and the base, like we said, it's a power of 10, so it's always 10. The base is the big number, it's just the number 10. And then you're going to see an exponent. Remember when we talked about perfect squares, we worked with the exponent of 2. Here, we'll be working with exponents of all types. When you look at that exponent, the exponent shows the number of decimal places that we're going to be moving the decimal. So you can see a decimal right here. We're going to be moving that decimal either to the left or right to change our original number. That is going to depend on what our exponent is. So if our exponent is positive, we're going to move that decimal to the right. If our exponent's negative, we're going to move it to the left. In just a second, I'll show you what I mean. If you need more time, feel free to pause the video and write down what we wrote in the boxes and on the lines. So let's go ahead and put some numbers into scientific notation to standard form. So here I have two different problems, both in scientific notation. And if we look at this, my first one says 4.52 to the power 4.52 times 10 to the power of 5. So to do this problem, first thing I want to do is I always rewrite the number that's in between 1 and 10. I'm going to write that down, 4.52. Now, like we said before, all we're going to do is move the decimal. Remember, this is our decimal right there, the little period, the dot. We're going to move it to the right 5 places. Why to the right 5 places? Because that's what the exponent is telling us. It is positive, so it goes right, and the number there is 5. So I'm going to move this decimal, 1, 2, and now I'm out of numbers, but I'm going to keep making these jumps, 3, 4, 5. And now our little decimal that started up behind the 4 is now all the way back here. You may notice that we have some empty spots. What you're going to do if you have any empty valleys, we call it, we go to add zeros in those spots. Finally, you would rewrite the number so it was neater. You don't want all these squiggly lines there. And if I rewrite the number nice and neat, I end up with 452,000. So that was a positive exponent. Let's go look at a problem with a negative exponent now. I'll drag this over here. So here, once again, we have a number that's in between 1 and 10, and we have a power of 10. Notice our exponent here is a negative 5. First thing we always do is rewrite our number that's in between 1 and 10. So I'm going to rewrite, I'm going to give myself some room. 2.341. Now, the exponent is a negative 5. So that means I'm going to move my decimal place left 5 spots. So 1, 2, 3, 4, 5. Now my decimal, which was all the way behind the 2, is now up here. Once again, I have these empty valleys, so I'm going to fill them in with zeros. And I could rewrite my number now nice and neat. 0.0000. There's 4 zeros there, followed by 2, 3, 4, 1. And while this is the right answer, you never want to leave a decimal by itself. It always needs a number in the front. So if there's no number there, just go back at the end, make sure you add a 0. That's just good manners in math. So I want you to try some of these, and then I'm going to go through them. So I'm going to pause the video right here, and I want everyone to solve this first one, 2.3456 times 10 to the power of 6. All right, if you answered this video, remember, you would have written down 2.346. We have a power of 6. That's positive, and it's going to go right 6 places. 1, 2, 3, 4, 5, 6. Put my decimal back there, fill in the empty valleys with zeros, and now make sure you rewrite it. I will mark the question wrong if you leave it like this on a test. you got to go and rewrite the numbers and make sure you show me that the decimal has disappeared or that it's all the way over to the right. All right, let's go do this next one. Similar type of problem, except notice, everyone, that this exponent is a -6. That means the decimal is going to go left. So the video is going to pause and go ahead and solve this one. All right, if you found an answer for this one, you would have put 8.604, and it was a -6. So because that's a negative, we have to move the decimal left, and we're going to move it left 6 spots. 1, 2, 3, 4, 5, 6. Our decimal's there. We fill in the empty valleys. So I'm going to end up with 0. Very good. So if you had that, you got the right answer. We're going to skip these 2 problems just for time. You feel free, if you would like to go back on your own. And if you want, you could always check our key, which is posted in Schoology, and you could check these problems. But we don't have to do these problems right now just because it's doing the same problems again, and we want to save ourselves some time. Let's go on to our next slide. And now we're going to do this in reverse. So we just took our numbers. If we look, we were in scientific notation and we turned it to standard form. Standard form is just normal number form. Now we're going to do the opposite. We have a number in standard form and we're going to take them to scientific notation. So let's talk about this. The first thing we have to do is we got to look at our numbers. So let's look at number 1, this example. The first thing we got to do is look right here. You got to look at this problem. Now, even though you do not see it, there's a decimal point there. And if you don't see a decimal point, it means it's all the way over to the right. It's over here, and it's kind of disappears when it's over there. What we need to do is we need to place a decimal point so that this number is no longer 4,568,000, but instead it becomes a number between 1 and 10. So by doing that, if I take the decimal all the way to the left and put it like one number back, like always behind the first number, that's going to give us, if we would rewrite this, 4.568. That turned this number into 4.568. So I'm going to rewrite 4.568. And as always, all these problems, we always say times 10. Remember, it's a power of 10. So you're going to say times 10. Your only job now, once you figure out that first number, is figure out what would be the exponent. To figure out the exponent, go back and say, hey, this is where my decimal point is now. How would I get it back to its original location? Well, I would have had to go ahead. If I wanted to turn 4.568 back into this 4 million number, I would have to move the decimal to the right. 1, 2, 3, 4, 5, 6. So if I had to move the decimal right to get it back to normal, 6 spots, that's positive 6. Another way to tell if it's positive or negative is if you just look at the number. If the original number was bigger than 1, it's going to be positive. If it's smaller than 1, it's going to be negative. So as an example, before we even do this next problem, if you go and look at it, 0.0097823, that's smaller than 1, so I could already tell that this is going to have a negative exponent. We also will be moving the decimal left, which you could also use to remember. So let's try this next problem now. What we have right now, we have 0.0097823. So right now, this number is too small. It's not between 1 and 10. So what I need to do is I need to move this decimal so that it is in between 1 and 10. The first number I see that's not 0, I'm going to put my decimal behind. So there's a 0. I can't do that. There's a 0. But if I put it behind this 9 now this number is going to become 9.7823. So I'm going to rewrite 9.7823. We always say times 10. We just got to figure out the exponent. So if our decimal is in the red spot now, and I want to get it back to the black spot earlier, how would I get it back to its original number? Well, we would have to move it left. 1, 2, 3. So that means if I moved it left 3, it would be a -3. Another way to know that it's negative is that the original number was less than 1. All right, I'm going to have you do 2 of these problems, okay? Feel free to let yourself skip this second problem and skip this last problem. However, if you'd like to do them, you absolutely can, and you can see the answers on our key for this, which is once again is posted in Schoology. We're just going to do these first one and the third one. So the first one says 764,000. I want you to go try that one on your own. I'm going to pause the video here. All right, if you did that one, so right now, even though you don't see it, the decimal is all the way back to the right. If I wanted to turn this into a number between 1 and 10, I would have to move it behind the 7 here, because that would make it 7.64. As always, we're going to say times 10, and then we want to ask ourselves, if our decimal is behind the 7, how do I get it back to its original spot? If I wanted to turn 7.64 back to 764,000, I would have to move it right 1, 2, 3, 4, 5 times. So it is a power of 5. And I know that because I moved the decimal right. Another way to know that is if you look at the number and it's bigger than 1, 764,000 is definitely bigger than 1. That means it's going to be a positive exponent. So for this next one, you could obviously tell 0.98723 is smaller than 1. So you know it should have a negative exponent. With that in mind, go ahead and solve that. And let's see what we end up getting. All right, if you did this problem, let's go look at it. Right now, the number is too small. It's not between the numbers 1 and 10. To make it in between 1 and 10, I'm just going to go across and put it behind the 9. Because if I put it behind the 9, this becomes 9.8723. So remember, I'm just going to start moving it right until I see my first number that's not 0. 9 was that first number, so I put it behind it. I'm always going to say times 10. And if I look at this one, our decimal is now behind the 9. How would I get it back to its original location? I'd move it 1 to the left. So going left once means -1. Another way to think of that, though, is this original number, 0.98723. 0.98723 is smaller than 1, so that lets me know it should be a negative. The final set of questions I'm going to ask you, and I'm going to do the first one, and I'm going to have you do the next two, are these problems in scientific notation? I want you to tell me yes or no. So remember, for a number to be in scientific notation, okay, for a number to be in scientific notation, it must first be a number between 1 and 10, and then you have to be multiplying a power of 10. So as an example, I'm going to do this last one over here, and then I'm going to have you do the first two. So make sure you fill this one out with me. If I look at this one right here, that answer would be no. Why is it no? Well, if I look at this number, it is not between 1 and 10. 0.238 is not between 1 and 10. And that would be my answer. So make sure when you answer this question, you are not just saying yes or no, you are also explaining. So I want to pause the video here. Look at this first one. Is this first one 4.5 times 10 to the 6? Is it in scientific notation? So if you looked at this, the first thing you always want to look at is this first number. Is 4.5 between 1 and 10? Yes, it is. Are they multiplying it by a power of 10? Yes, they are. So this answer is yes. No further explanation needed. Our last one, 61.3 times 10 to the -9. Try that. So if you did this one, first, is our first number between 1 and 10? No. Do we have a power of 10 here? Yes. Because 61.3 is not between 1 and 10, like we said, the answer is no. And why is that? 61.3 is not between 1 and 10, 1 through 10. All right, thank you for watching the video. If you need any more help, please let me know.